All right, so welcome everybody to the TST meeting. Today we have scheduled 2 items on the list. One of them is ACTN, which is for basically traffic engineering of a multi-layer network. It's and has a set of, it's an IETF standard and has a set of related Yang models. And I'm sorry, can you pronounce your name for me? Just want to make sure I don't mangle it. Aihuaguo?
Aihuaguo.
Aihuaguo, okay.
Yeah.
I was gonna, from Huawei is going to talk about that. And then we have a second speaker, Murad, is going to talk about OpenFlow 1.3 and 1.5, perhaps later. So I think with that, we can turn it to Aihuaguo, and then he can share his proposal with us.
Okay. Should I get closer to the?
I think it should be fine. That should be okay.
Okay. So yeah, good morning, good afternoon, good evening, online guys. This is Aihuaguo from I work with Huawei, and actually today I'm here with with an expert in and who is also the creator of ACTN standards, Yang Li, from Huawei Dallas. So together we will be presenting this topic about using the ACTN as a solution to extend ONOS to support hierarchical control of TE networks. And so, what is ACT? What is first of all, what is our view of the traffic engineering networks? This is it includes networks which can be traffic engineered and includes networks with packets and optical. And in the optical domain, we have coverage for WDM and OTN networks. And for packets, the type of networks that we're looking into is MPLS-TE and MPLS-TP. And so here I'm going to show some example of what the network is like. Oh yeah, now it shows up. So here's a network domain with IP layers and optical layer, typical IP optical network scenario. And right today we can do what we do is we put an ONOS at the top. Yeah. And we use ONOS to manage this IP optical networks with a set of plugins from the southbound with OpenFlow or other protocols, and it can manage it directly IP routers and optical network elements, and then form abstractions in ONOS, and then we can do topologies and service provisioning across the network, right? And so if we have yet another domain connected together, and then we can still use ONOS to do the same thing by either providing additional southbound plugins, and also use technologies like clusters to address at least a part of the scalability concerns. And now imagine we have yet another network which is connected, but also it may have a different ONOS SDN controller. And in this case, what ONOS can do is to address the communication between the two domains via confederation, right, which is, to my understanding, is under development today. But also then imagine that we have yet another domain which may or may not be using ONOS as the SDN controller, which is also using either standard or proprietary interface talking to the SDN, talking to the domain. And so in this case, we cannot do confederations or clustering across them. Then naturally we would come up with a hierarchical kind of control with a super controller at the top, and this supercontroller can talk to all of the three ONOS domain controllers via some sort of interface. And currently, we are looking to use the standard interface to communicate between this super SDN controller and the ONOS controllers and other SDN controllers at the bottom. So in between these two.
That doesn't show there.
Yeah, it's
a bit delayed, right?
Oh, yeah,
okay.
no, it comes out.
Okay.
Right. And also imagine that for scalabilities and for the from the practical control perspective, right? It's necessary that we do certain level of abstractions for each of the domains in order for the supercontroller to have a clear picture of each of the network, but also can do very efficient management over such a huge network. And the abstractions that the interface that we are dealing with, this both communicating the abstractions in between the two controllers are today we can use standard Yang model based ResConf or NetConf ResConf interface, but also we can use binary protocols like PCEP, and both actually are being defined in the IETF community as standard drafts. And we're going to talk about this a little bit later. Now, based on this supercontroller architecture, then we can connect this. We can build custom applications, and also the supercontroller can connect it to the can integrate it to the orchestrator on the top, which provides end-to-end services across all the networks for the customer, right? So in this picture, what we see that we need to do is to provide a certain level of traffic engineered SDN control to address this multi-domain, and for each of the domain there could be multiple layers. So it's multi-layer, multi-domain scenario, and also it could be a multi-vendor environment, and in some when there are both ONOS SDN controllers, there could be east-west communication via and confederations. Right, so those multi-domain, multi-layer, and multi-vendor, as well as confederation, are somewhat addressed by ONOS today, right? But what is missing, and what we are actually looking to enhance, is to introduce this hierarchical control along with the standard northbound interface and abstraction of the network underneath. So as to support this hierarchical level of control. One other side effect is by doing this, we also allow to connect and to integrate an ONOS controlled managed networks with other even proprietary controlled networks, making a very smooth network migration for both greenfield and brownfield application network management. Okay, so this is just a brief description of ACTN. So what is ACTN? So ACTN, first of all, it's an IETF defined standards, which is fast progressing towards the final RFC, and it refers to a set of virtual network operations which is needed to control and orchestrate and to manage large-scale multi-domain, multi-layer TE networks for both packet and optical, in order to do network, to allow the customer to do dynamic network programming over such a packet optical integrated networks, to do a lot of the automations via applications, right? And to have end-to-end service connectivity and very efficient resource sharing across all those domains. And so the current status of ACTN is actually it consists of an architecture an architecture document and a framework and use case document, which are very fast progressing. And Yang is actually the creator of ACTN, so we can speak a little bit more on that. This is the ACTN reference architecture. Yeah, maybe you want to go?
Yeah, I think motivation was STN, ONF, STN architecture. They had actually recursive control hierarchy. I have been involved in ONF as well, but that is a little bit too theoretical. So in ACTN, we make it a little more concrete, usable, and reflecting current topology, and creating layers of control hierarchy. So here we define 3 controller types. Maybe from bottom up, physical network controller, which is basically domain controller, open flow domain or GNPLS domain or PCEP domain or netconf domain or TL1 domain, whatever. It can be EMS, NMS system can be also PNC. And then on top of that, we built MDSC, multi-domain service coordinator, to basically abstract. This MDSC is what Aihuaguo just showed in previous slide, supercontroller, ONOS supercontroller. But also, I think we need to integrate CNC to MDSC. Basically, customer network controller inject what they want to create in terms of virtual networks, multi-tenancy, whatever virtual network they want to create through this multi-domain and multi-layer networks. So MDSC need to intercept what they want and then integrate with network abstraction topology to create a service on the fly. So this is basically what IETF has defined, and this document has been accepted as a working group document. Actually, it's in the process of polling. And last time in the IETF meeting, we get consensus. So IETF is consensus-based, so it's going to be officially standard working group document. So before we make the whole thing to implementable,
yes. Sorry, one moment. We seem to have lost the connection.
Oh.
Brian, can you guys hear us okay?
Seconds, maybe a few minutes ago. You've been fine since.
Okay, sorry about that. I just want to make sure nothing was lost.
Right. So we'd like to, IETF defines Yang model and RESTCOM and also PCEP, hierarchical PCEP as well. PCEP is not just legacy anymore; it's a stateful hierarchical protocol for binary for fast convergence. But also we have model-based, Yang model. So before we want to standardize, we'd like to use ONOS as a way to implement a free standard version so that it proliferates much faster across ONOS community and also industry, so that IETF and ONS can align together to help each other, right? And it will enhance ONOS capability, but also proliferation of the standard model can be much faster in industry. And we have actually many customers waiting for that happens, right? So we have, that's why I think Aihuaguo came here to present. This might be good for you guys and also for us, for the industry as well.
So as this picture shows, this is okay. Brian says it's lost audio again.
Okay, I'm not sure.
Maybe that's delay.
It's connecting to audio. I'm not sure why. Can you hear us okay?
Yep, you're back.
I don't know what's happening. Okay.
Okay, as Yang said, this is the ACTN reference architecture, and let's go to the next slides. Yeah, that's just what Yang has suggested, has talked about. The ACTN contains three types of controllers in this hierarchy. Right? PNC, MDSC, and CNC. And also note that this MDSC could be as well recursive, so it's not necessarily just one level of MDSC, right? And the models, the Yang models and PCEP extensions that were developed in IETF allows this recursion to and multi-level abstraction to happen. Okay, so that's just a picture showing the mapping of the ACTN term onto the practical network deployment that I'm showing. I was showing before. We have SPI and PNC ONOS as a PNC domain controller, and ONOS here as an MDSC, which is a supercontroller, and the interface between the supercontroller and domain controller is called MPI, MDSC to PNC interface, and also the CMI is the supercontroller to customer application and to CNC on the top. Here we are listing a few of the IETF standards just to give an overview of what is currently going in IETF. There are several major IETF working groups dealing with the definition of the architectures and Yang models, mainly the Traffic Engineering and Architecture System (TEAS) working group, where majority of the Yang models were standardized there, and the CCAMP working group, which is dealing with a lot of the technology-specific extensions, Yang models, as well as PCEP extensions, and the I2RS, which defines a generic Yang model for network topologies, which the TE models are augmenting from. And there's a path computation element working group, PC working group, which defines a lot of the PCEP extensions. And below that, we have a list of Yang models are under consideration. As I said before, the network-based network topology model and abstract T topology model, which allows to expose and configure a T topology for the purpose of display and path computation provisioning needs. And based on this abstract T topology, we have OTN and WDM layer-specific T topologies augmented from the abstract T topology. And on the tunnel part, we have T tunnel draft, which allows user to create end-to-end tunnels across multiple domains. And also a transport tunnel, which is more onto the service user-facing service perspective. And regarding the architecture definition, we have ACTN requirement and also ACTN framework, as well as a few others which are currently under development. So note that both the base topology and abstract T topology and tunnel models, as well as ACTN requirement and framework document, are currently working group document, which will be adopted into IETF RFCs rather soon. And besides that, there's also a big set of PCEP protocol extensions, which defines extensions to address the needs for to implement stateful PCE functions and stateful hierarchical PCE, as well as PCEP for link state distribution, and PCEP virtual network to create and instantiate and manage virtual network from the user perspective using PCEP protocol extension. So here I summarize some key benefits that ACTN development brings to ONOS. Basically, we introduce a very practical approach to for a SDN controller solution for both packet and optical networks. In a way that we enable a heterogeneous packet optical network transport network control and management across across domains with different technologies, either proprietary or standard, with standard and proprietary interfaces. Also, by having a unified traffic engineering control and management scheme, we enable ONOS to provide a very practical IP and optical integration solution for data center, whether it be data center interconnect, metro, or core carrier networks. By implementing the hierarchy and combined with confederation of SDN controllers, and also to allow to do perform resource abstraction through standard interfaces. We also addressed we addressed the control scalability for when we deal with large-scale packet and optical networks. So ACTN in ONOS, when we build ACTN, it is not totally new, right? ACTN actually builds on available ONOS capabilities, like the core components, topologies, tunnels, device, and flow rules, as well as many southbound interface which already exists, PCEP for path computation, netconf, REST, and OSPF-TE, as well as BGPLS, which is just released, right? And also those under development are the PCEP-LS extensions, and also generic YANG model support, which includes the YANG tools, YANG U tools, right? And RESTconf protocols, which actually also is developed together with our team here. So what we are actually suggesting to have is to treat ACTN as a good use case, which has multiple building blocks to realize this hierarchical control. And so there are a few projects that we are looking into implementing in ONOS. One is the IETF. First project focus on bringing the IETF YANG models, model-driven interface into ONOS, and this will implement standard IETF YANG models as a northbound interface, as both a northbound interface and southbound interface, with respect to the supercontroller and domain controller. And second key function is the what we call ACTN MDSC controller, which is the supercontroller, which realizes multi-domain and multi-vendor hierarchical SDN control, as well as virtualization and abstraction functions. And third one is we want to extend PCEP to be used as a complete set of northbound interface and southbound interface, similar to the YANG models, but in a binary format. Right? So we want to implement stateful HPCE to support hierarchical control. We are implementing the PCEP-LS extensions, and we also to implement PCEP for virtual network instantiation. And then at the same time, if you look at the ACTN hierarchy, right, ONOS can be used as both a domain controller and supercontroller. But in order to make ONOS to be a domain controller in this hierarchy, it needs to implement necessary functions for abstraction to be connected to the supercontroller. So the fourth project we are proposing here is the ACTN PNC controller, which realizes abstraction functions and actually enhance the traffic engineered control of the network elements underneath. Okay, so here's a illustration of what are to be developed based on the current ONOS ONOS components. So the first project is the IETF Yang models. Basically, what we are trying to do is to introduce RESTconf as a RESTconf client from the southbound, which accepts topology and tunnel data defined by the standard IETF models, and then inject the topology and tunnel information into various components of ONOS core. And then actually from the northbound, we wanted to reuse the ONOS GUI and but enhance it as a RESTconf client, which talks RESTconf protocol to ONOS, and then what it does is actually in this project, what it does is it receives topology from the southbound from multiple domains, put it into a topology centralized topology database, and expose this topology without abstraction directly to the over northbound to ONOS GUI. So we will, by doing this, we will be able to see a full picture of all the topologies and tunnels from the southbound to the GUI from the northbound. So this verifies that both the we can use RESTconf and Yang implement IETF Yang models both in the southbound and in the northbound. And the second project at the MDSC, what we need to develop is essentially the key functions here as a set of applications. So the first layer of application is a centralized T topology manager, and which obtains the topology from the ONOS core and build its own T topology database and keep it in a topology local topology database to facilitate a lot of the path computation retrieval and operation. And in there, we also have a tunnel manager, which takes the end-to-end tunnel and actually chop it into multiple segments and deliver it to each of the domains underneath through RESTconf. So along with it, there's certainly a need to have a path computation engine. And this path computation engine is not completely new. The current PCE project has already built an application to do basic and basic support for path computation, and we will be looking to enhance that from the need to compute a feasible path based on the abstract T topology. And then based on this, we will have two. If we want to create yet another abstraction, we will need to build an abstract topology. We'll have another layer of application which deals with the abstraction, right? Which is the abstract topology builder and abstract service mapper. These two are actually from MDSC perspective. They are if there's no application on the top, this is rather optional, right? But on the other hand, we do have another application called Virtual Network Manager here, which takes the request from a client, basically it received a request from client in terms of building a virtual network from client perspective with a set of parameters expressed in the client's term, and map it. Actually, this virtual network manager will map it to a set of T to a specific T topology with links with a set of T links supporting this supporting the virtual network. And this is the virtual network manager that we're going to build along with the MDSC. Okay, so the third one is PCEP. As you see here, the we actually for both the IETF Yang model and PCEP, the only difference here is the protocol extensions. So when whatever information, once it passed the southbound past the protocol stage, all logic in the in ONOS can it's protocol agnostic. Basically, the logics are the same, right? And also regarding the PNC function, so I draw it here, but in actually, when we develop that, we can view the PNC function, the domain controller. Actually, it will share the same design and code with MDSC, except that for the PNC, it actually focuses on this abstraction layer, right? On the abstract topology builder and the service mapper function, because it PNC needs to connect it to the to MDSC, and so it needs to do a lot of the abstraction and mapping. But whereas in the MDSC, we are focusing on collecting all topologies together and do path computation across all of the domains and chop the segments into and give it to different SDN controller. Okay, so here are a list of demonstrable functions that we can do for IETF for those projects. Just going through this briefly. For the Yang models, we want to implement functions to retrieve T topology from southbound and use GUI to demonstrate to view the topology from northbound, and same for the tunnels. And some proposed release plans for the upcoming 3 releases for ONOS. For H releases, we'll focus on the support for IETF topology model. And in the I release, we'll complete the topology model support and have introduced basic tunnel model support. And along with other projects, we'll be able to do a proof of concept demo using the I release or within the I release timeframe. And then for the MDSC, we will have what we demonstrate is to have a full topology view where we merge multiple domain T topology into one single topology and show. And so in this case, we not only show the aggregated view, but also we show the relationship between the abstracted view in the MDSC and also the native topology in the domain. And like I said here, if we double click a link or node, we can see a detailed view of the of an underlay path or an underlay topology from the corresponding domain and show the association. Right? And for service provisioning, then we will use GUI to request end-to-end service and to compute path across multiple domains, and also accommodate various service constraints like how we exclude the links and nodes, disjointness, SRG constraints. Actually, though some of these functions have been at least from Huawei perspective, have been developed and demonstrated over this year's ONS. And there's actually also a GUI that was demonstrated and we can possibly contribute into ONOS. And there are some advanced functions that we can consider for MDSC, namely the service restoration for inter-domain link failures, and also virtual network creation using the virtual network manager application to allow user to specify type of networks, and the MDSC realize the virtual network with the customized T topology underneath. And also a suggested development roadmap for MDSC. For the in brief, in the Edge release, we will have some. We focus on the topology manager function and the basic virtual network manager application. And in the I release, we'll have a full picture of the topology manager, tunnel manager, as well as enhanced PCE function. And in the J release, there will be focused on more like advanced function for to demonstrate restoration and perhaps an advanced PCE, which does a sophisticated calculation. And the PCEP as a northbound interface and southbound interface to demonstrate that we retrieve topologies from southbound via PCEP-LS and show topology in ONOS GUI. And also we want to demonstrate incremental updates for T topologies to allow fast convergence and also tunnel operations with PCE virtual network extensions. Along with it is also a suggested roadmap for PCEP development. Basically, this is primarily focused on PCEP protocol extensions. And for the PNC, which is the domain controller, what we wanted to demonstrate is to combine the current capability of ONOS to show basic topology and tunnel management, and also to show how we abstract the topology, how we configure an abstract topology, how we instruct the PNC to create abstract topology, and then expose it through standard interface to the MDSC, and how the PNC receives service segments from the MDSC and then instantiate the service and do the commissioning and provisioning across the network elements. And also a few roadmaps items in primarily for PNC. The focus is on the I release, which is in November, and which can be combined with the MDSC to demonstrate the full function for this hierarchical control. So for this project, actually, it has gained a very good interest from both standardization and open source communities from both vendors and carriers. So we have a few. This is a few of the list for the collaboration partners. We have Huawei and Ericsson, and BUPT, which is Beijing University of Post and Telecommunication. And on the carrier ends, we have committed partners with SKT, KT, and E3. The list is still growing, so it has gained a very good interest. So a lot of them wants to see this and actually wants to use it for demonstration, right, in November.
In also July, we have hackathon, ACTN hackathon. So, so we have actually SKT and Ericsson will join with us. And then in IETF November in Korea, SKT and KT and ETRI and Huawei and Ericsson are going to have demo of this concept. So we may also say it's ONOS based. So it's good for you guys to your platform to be advertised as an industry initiative. Yeah.
So basically, in this picture, we really wanted to promote ONOS and actually demonstrate that we could realize this full hierarchical control with ONOS from bottom all the way to up, right? And to show that it's not just a demonstrable function, but also as a potential solution for commercial solution and for wide deployment.
Yeah, and also ACTN is not foreign for ONOS because we have been doing Yang tool development and PCEP. We're kind of combining together as a more use case and more structured.
So I had some questions. So I didn't want to detract before you have a chance to finish.
Yeah, I think this is the last. This is the last one.
So I had some questions. If people go back just at least to maybe like to the diagram before you were going through these things. So yeah, this one is probably fine.
This one?
Yeah.
Yeah.
So I guess leaving the protocols aside, like PCEP, Yang, RESTCOM, everything else. So clearly I understand it, right? In the sense that the premise of the hierarchy here is to be able to abstract away some low-level details from the physical networks, present only the relevant pieces, and allow in a hierarchical manner to stack this up and progressively boil away some levels of abstraction.
Yes.
Right?
Yes.
So, but that's what I thought. But then you mentioned somewhere along the way that you're going to be able to, at the very, very high level, you're still going to be able to show the exact mapping of the virtual network, of the high-level networks to the physical networks. That to me implies that no details have been boiled away. And that's a bit of a concern. So, did I misunderstand?
When you say...
So let's say you're from the physical network controller.
Yes.
Presents an abstracted view of its network to the
supercontroller.
Well, to the supercontroller, right?
Yeah.
And the supercontroller then can use this aggregated view from multiple physical controllers to be able to orchestrate traffic.
Yes.
Right. But it's doing that using a coarse-grained picture of the network, not a low-level picture of the network, right? Or
to some extent, it's a coarse level, but still you can actually associate some details of the low-level picture. Let's say in MDSC, right? You have a topology, you have links and nodes.
Yes.
For each of the link, you can in the model that IETF is defining allow to specify an underlay path that supports this link, and this underlay path is expressed in terms of the links and nodes in the domain. Each of the domains.
Sure. Does that mean that the MDSC then has to be aware of the full combined topology?
No.
Okay. I just wanted. Okay. So clearly, some constraints should be permissible, but I just wanted to make sure that this does not result in full explosion.
No, it does not.
So abstraction topology, and it runs on top of abstraction topology to create end-to-end network slicing and present to the real customer, and it doesn't interfere with what PNC says. It shouldn't.
Okay.
You shouldn't look at those details.
All right. Yeah. So that's one question. That was, I guess, clarification more. Second is how do you see the T topology to be related with existing topology and that subsystem that exists in ONOS? Do you envision building a new one? It seems like you are.
Yeah, that's actually a good point. So basically, the current ONOS subsystems, like links and devices, it actually has a very good design, right? But there are some parameters in the T topology model that are so first of all that are that are not addressed in the ONOS in this ONOS core layer, right? Some of parameters that we have to do that via either annotation or some other via some other ways, because so there's also, let's say for example, there's a connectivity matrix, right, which describes the connectivities for a non-blocking for a blocking switch, and this is
I think that's why we said topology plus. Whatever is not covered by core, we can at least try as an app. And if you guys want to integrate with yours, fine. But we didn't want to touch your core driver, right? That's why we kind of put plus, additional ones that we might need.
Yeah, so we went through some similar conversation during the BGPLS and
exactly.
stuff, right? So I guess there's two things in here. I want to make sure, I guess, and it's clearly your call, but I would urge strongly to make sure that we don't let the Yang models, which are essentially a description of the interface contract.
Yes,
it's an interface.
Yes,
right.
It's should not specify internal behavior.
Yes.
No.
Do not allow that to cover the internal behavior.
No.
Not at all.
So it's certainly so. That's one thing. I just wanted to get off my chest. And so second thing is with respect to the topology. So clearly, I mean, the topology today in ONOS is purposely very, very naive and flat.
Correct.
And so as such, it may lack some attributes. And it's admittedly the current annotation mechanism to extend it and to support projection is a little bit crude. And
correct.
It could definitely that area could use some improvement.
Yeah.
I'm a little bit worried, I guess I should say, about introducing another topology subsystem in there. And so I'm almost more, I would prefer if you could work to understand what are the limitations of the existing one and what's preventing you from portraying the necessary piece of information, data in the existing one, and try to overcome those limitations. That would be preferable to me, because if you come up with a separate one, it will be very difficult to merge.
Yeah, sure. Exactly. That's actually exactly what we are actually trying to do. The only thing that is we actually did some good analysis, right? And then you see all the links here. So there are very good set of parameters that we can do with existing capabilities. But there are some certain parameters that are not available in the ONOS.
Like an inter-domain link. I don't think ONOS has inter-domain link notion.
Sure.
Right, so those things are plus.
Yes. Well, in effect, some of these same barriers is what the ICONA team, which is lately working on the federation, has come across, where they need to represent inter-domain entities, or and essentially they deal with the abstract topology concept as well.
Correct.
Yeah, it would be ideal if there are some shareable components that enables the ONOS to support both applications, and we would very much like this to happen, because the way why we put this topology DB plus here is rather really a compromise, right? We wanted to build, because this topology, we actually need a explicit all parameter explicitly specified in this topology DB, because it requires very extensive computation and retrieve and get and set. So if we put this separately, it's not going to work, right?
Right, exactly. So, but I think working on augmenting the existing stuff will probably means likely means that although in long term it's a good thing, in short term it probably means slower pace of progress, because it will require careful review and careful design, and because we need to assess both coherence of the abstraction and of the overall architecture, but also considerations for performance.
Yes.
Right.
And clearly considerations for extensibility.
Sure.
So that would be my preferred approach, at least. I don't know, what do you say, Madan or Brian?
I mean, I agree with that. I think having incorporating whatever new things that you have. I think attempting at least to see if we can fit it into the existing technologies.
Yeah, actually,
that's actually our
I think
preference.
performance, definitely, I think we can improve it incrementally.
Right.
But let's not make that consideration detract away from like.
Sure.
Yeah. The purpose of this is not to say, okay, no, we're going to throw away everything, build a very new system. Right? That's actually our intention is very opposite to that. We basically want to make use of existing capability and extend as much as possible. But only when there are obstacles which cannot be done, then it's probably a good idea to propose to raise it and discuss how we can accommodate that.
Right.
But logically speaking, we are, let's say, building this topology database. If it can be implemented in the ONOS core, we'll definitely be very supporting to put this in the as a common function in the core.
Right.
Okay. And so there's a couple more, I guess, questions/suggestions here.
Yeah.
So I guess one of them, the suggestion is, again, I would decouple the protocols, whether it's REST-Conf, YANG, or PCEP. I would completely decouple them with internal stuff.
Yes, so that's exactly what.
Just want to make sure, because the standards are great, but they also can be paralyzing, as we've seen.
Correct.
Right. So. So I want to make sure that internally we're not tied to them at all. And then one of the things that could potentially be tied in, if not done carefully, is this abstract topology stuff. So basically, it's the ability to take for one domain at one level to be able to project its information in some reducted format upwards. And also, basically, it becomes a virtual network. You basically expose a virtual network to the top, right? Whether it's represented internally as a virtual network or not, but it becomes a virtual network. And that virtual network can be operated upon by the upper controller.
Yes.
This overlaps hugely with the Icona work. With Icona work, with the work being done by Giant. And so...
but I guess the difference here is it's actually this abstract topology builder and service mapper are made in accordance with the standard models, right? To fulfill the parameters that are defined by the.
Again, I would decouple. This standard should not specify necessarily full level of internal behavior, right? External behavior.
It's external behavior only.
So the external behavior, and then this is where basically where we specify the structures of data that are conveyed over whatever. REST-Conf and NetConf. But so clearly the internal abstraction, in my view, should be decoupled to some level, even from that standard as well. And of course, the internal abstractions need to be able to support that standard. So it needs to support reasonable, reasonably similar structures and relationships and information, right?
Exactly.
But it should not be necessarily fully dictated by the standard.
I agree.
Okay.
The internal design is your freedom. Whatever mapping algorithm you have, you create it.
Right.
But when you present to other entity, you make it standard compliant.
Exactly. And that's the either northbound or southbound adapters, right?
Yes.
And essentially, in this case, the PNC would be presenting northbound adapters, and then MDSC would be basically consuming those northbound and presenting its own southbound.
Yes, absolutely.
So sure, but I want to make sure that they're decoupled. But then the abstractions, in terms of the north-facing abstractions for virtualizing the domain network, that stuff at least overlaps in purpose, not necessarily maybe in similar structure, but overlaps in purpose with the work that's being done by our Icona team. And I'm wondering here whether or not there ought to be some sort of a collaboration, or at least explore what they have in place.
Absolutely.
That's
who's the right person to talk to?
I think there would be Matteo Guerrero.